There's a version of you that exists for only 1 second. It doesn't know it only has 1 second. It has all your memories, your childhood, your first love, yesterday's breakfast. It feels your body, hears your thoughts, experiences this exact moment with perfect clarity. And then it's gone. This isn't philosophy. This is physics. In 1896, this creates a paradox that has troubled cosmologists for over a century. If most observers in the universe are Boltzmann brains, then statistically you should be one too. Maybe right now, as you listen to this in the darkness, you're not a person with a past and a future. Maybe you're a momentary pattern of neurons that fluctuated into existence with the complete illusion of a lifetime, and in another moment you'll dissolve back into the quantum foam, never knowing you existed at all. Tonight, we're going to follow this rabbit hole all the way down. We'll begin with a man whose ideas were so far ahead of his time that the scientific establishment rejected them, driving him to despair. We'll explore why empty space is never truly empty, and why the quantum vacuum seethes with endless potential for creation. We'll confront the mathematics that make random brains not just possible but statistically dominant in an eternal cosmos. And then we'll ask the question that matters most. If Boltzmann brains are inevitable, why do we seem to be something else? The answer may reveal something profound about the nature of consciousness, the structure of time, and why our universe exists at all. But first, let me take you back to Vienna, in the dying days of the 19th century, where a brilliant and tormented physicist was about to glimpse a truth so strange that it would echo through science for the next 100 years. Ludwig Boltzmann was not supposed to change how we understand reality. He was supposed to count atoms. In the 1870s, Boltzmann developed a revolutionary approach to physics. Instead of trying to track every individual particle in a gas, an impossible task given that a single breath of air contains more molecules than there are stars in the observable universe, he used probability and statistics. He showed that the behavior of gases could be understood by considering the most likely arrangements of countless particles. This was statistical mechanics, and it would become one of the foundations of modern physics. But in Boltzmann's time, many scientists didn't even believe atoms existed. They saw them as convenient mathematical fictions, not real objects. And here was Boltzmann, building an entire framework of physics on these supposedly imaginary entities. The attacks came from all directions. Ernst Mach, one of the most influential physicists of the era, publicly dismissed Boltzmann's work. Wilhelm Ostwald campaigned against atomism with almost religious fervor. At conferences, Boltzmann found himself isolated, defending ideas that we now know were correct against an establishment that refused to see. But Boltzmann's most disturbing insight wasn't about atoms. It was about time. He had derived something called the H-theorem, which seemed to explain why time flows in one direction. Why do eggs break but never unbreak? Why does heat flow from hot to cold but never the reverse? Boltzmann showed that systems naturally evolve toward more probable states, toward higher entropy, simply because there are vastly more ways for a system to be disordered than ordered. This was elegant and powerful, but it contained a hidden problem that would haunt Boltzmann for the rest of his life. If the universe obeys the laws of probability, and if those laws are the same running forward or backward in time, then the current low-entropy state of our universe is extraordinarily unlikely. He never saw his ideas vindicated. Within just a few years of his death, experiments confirmed the existence of atoms beyond any doubt. Statistical mechanics became essential to physics. Boltzmann's work is now seen as foundational to our understanding of thermodynamics, quantum mechanics, and information theory. But the paradox that bears his name, the paradox of the Boltzmann brain, remains unsolved. And as you lie there in the darkness, perhaps feeling the first gentle pull of sleep, I want you to understand something. This isn't just a historical curiosity. Modern cosmology has made the Boltzmann brain problem worse, not better. Far worse. To see why, we need to understand what physicists have discovered about the nature of empty space. Close your hand into a fist. Now imagine removing everything from the space inside that fist. Every molecule of air, every photon of light, every particle of any kind. Imagine cooling that space to absolute zero, the coldest possible temperature, where all thermal motion stops. You might think you'd be left with nothing. Perfect emptiness. A pure void. You'd be wrong. Even in the most complete vacuum, physicists can create. Even in the emptiest regions of deep space between galaxies, something remains. Space itself is alive with activity, seething with energy, buzzing with potential. This is the quantum vacuum, and it changes everything about how we understand the Boltzmann brain problem. Quantum mechanics revealed in the 20th century that emptiness is impossible. The uncertainty principle, one of the fundamental laws of nature, forbids any region of space from having exactly zero energy. There will always be fluctuations, tiny temporary violations of energy conservation that are permitted as long as they're brief enough. These quantum fluctuations create what physicists call virtual particles. Pairs of particles and antiparticles constantly pop into existence from nothing, dance together for an instant shorter than any clock could measure, and then annihilate each other and vanish. This happens everywhere, all the time, even in the emptiest void. This might sound like mathematical abstraction, but virtual particles have measurable effects. They create a tiny force between metal plates placed very close together, the Casimir effect, because there's more quantum fluctuation activity outside the plates than between them. They cause subtle shifts in the energy levels of atoms. They even make a small contribution to the magnetic properties of electrons. The quantum vacuum isn't empty space waiting to be filled. It's a roiling sea of potential, a foundation of reality that's always creating and destroying, always fluctuating, always active. And here's where it connects to our story. These fluctuations don't just create particle pairs. Given enough time, they can create anything. The uncertainty principle allows energy to be borrowed from nothing as long as it's paid back quickly. A small energy loan must be repaid almost instantly, but a larger loan gets more time. And in the quantum world, energy and mass are interchangeable. That's what Einstein's famous equation tells us. So quantum fluctuations can create not just particle pairs, but atoms, molecules. In principle, with vanishingly small probability, they could create anything that's physically possible, including complex structures, including brains. But wait, you might think. Even if such fluctuations are possible, they must be so rare as to be effectively impossible. The probability of a brain assembling itself from random quantum fluctuations must be so small that it would never actually happen. And you'd be right if we were talking about any normal span of time. But we're not. Modern cosmology suggests that our universe will last forever. Not just for billions of years or trillions, or numbers that human minds can meaningfully grasp. Forever. An actually infinite span of time stretching ahead without end. And infinity changes everything. Let me tell you about the number that keeps cosmologists awake at night. Imagine the probability of a brain spontaneously assembling itself from quantum fluctuations. This probability is almost impossibly small, something like 1 in 10 to the power of 10 to the power of 50. That's a number so vast that writing it out would require more zeros than there are atoms in the observable universe. Now imagine that probability applied once per second. In any given second, in any given region of space, the chance of a Boltzmann brain forming is effectively zero. You could wait 1 billion years and never see one. You could wait 1 trillion years and still never see one. But infinity isn't 1 trillion years. Infinity is forever. Given infinite time, every event with any non-zero probability, no matter how small, will eventually occur. Not just once, but infinitely many times. This is mathematical certainty, not speculation. So in an eternal universe, Boltzmann brains are inevitable. They will form, and they will form in infinite numbers. But here's what makes this a genuine crisis for physics, not just an interesting thought experiment. Boltzmann brains won't just be common. They'll be almost everything. Think about it this way. What's more likely as a random fluctuation? A single brain appearing in empty space, or an entire observable universe with hundreds of billions of galaxies, each containing hundreds of billions of stars, with planets forming over billions of years through complex processes, with life evolving through countless generations, finally producing a brain through biological development. The single brain is overwhelmingly more probable. Not by a factor of 10 or 1 million or 1 trillion, by a factor of 10 to the power of an enormous number. The spontaneous brain wins this probability contest so completely that there's no real comparison. So if random fluctuations are the explanation for observers, If there's nothing special about our universe's history, then nearly all observers should be Boltzmann brains. Lonely, momentary minds experiencing single instance of false memory before dissolving into nothing. For every observer like you, with a real evolutionary history, real memories of real events, a real physical environment, there should be vastly, inconceivably more observers who merely believe they have these things. And that means, statistically, you should be one of them. This is the Boltzmann brain paradox in its modern form. If our best cosmological models are correct, if the universe will indeed expand forever, if there will indeed be infinite future time, then most conscious experiences in the history of the cosmos won't be real experiences of a real world. They'll be momentary hallucinations of minds that fluctuated into existence with false memories and false perceptions. As you lie there in the quiet darkness, perhaps feeling your thoughts begin to slow and soften as sleep approaches, consider what this means. The warmth of your blanket, the memory of your day, the sound of this voice, all of these feel absolutely real to you. But a Boltzmann brain would have exactly the same conviction. It would have no way of knowing it was a momentary illusion, and neither would you. Let's think carefully about what it would actually be like to be a Boltzmann brain. First, understand that a Boltzmann brain wouldn't know it was a Boltzmann brain. That's crucial. The entire concept depends on the brain having complete conviction in its own false reality. Imagine consciousness suddenly flickering on. But the word suddenly doesn't quite work, because for that consciousness, there was no before. The first moment of existence comes complete with a lifetime of memories. Childhood experiences that never happened, relationships with people who don't exist, knowledge learned from books that were never written. The Boltzmann brain doesn't experience itself as a brain floating in a void. It experiences itself as a person. It feels a body that isn't there. It sees a room that doesn't exist. It hears sounds, smells scents, has emotions, thinks thoughts, all generated entirely by neural patterns that randomly assembled in just the right configuration. Maybe the Boltzmann brain experiences lying in bed at night, listening to a documentary about cosmology. Maybe it experiences exactly what you're experiencing right now, down to the smallest detail. Here's what makes this truly strange. The Boltzmann brain's experiences aren't less real to it than your experiences are to you. Consciousness is consciousness. Subjective experience is subjective experience. The feeling of being a Boltzmann brain would be identical to the feeling of being a normal person, because both are simply patterns of neural activity that create awareness. Some Boltzmann brains would have memories of happy lives. Others would have memories of suffering. Some would experience their single moment of consciousness as a moment of peace, others as a moment of terror. But all would share one thing: complete conviction that their remembered past was real and their perceived present was genuine. And then, after that single moment, perhaps a fraction of a second, perhaps a few seconds, the fluctuation would reverse. The neurons would disassemble. The consciousness would vanish. Not into darkness, because darkness is an experience. Not into nothing, because nothing is a concept. Simply cease. Stop existing. With no moment of awareness that it was ending. Maybe that's happening right now to minds throughout the cosmos. Countless flickering candles of consciousness, each completely convinced of its own reality, each dissolving back into the void almost as soon as it forms. And this raises the question that cuts to the heart of the paradox. Is there any way to tell if you're one of them? Here's a thought that might stay with you after this video ends. You cannot prove that you're not a Boltzmann brain. Seriously, think about what evidence you could possibly examine. Your memories? A Boltzmann brain would have memories too, complete, detailed, emotionally rich memories indistinguishable from real ones. Your sensory experiences? A Boltzmann brain would experience sensations just as vivid as yours. Sights, sounds, physical feelings, all generated by the same neural mechanisms. Your sense of continuity with your past self? A Boltzmann brain would have the same sense, created by the same brain structures that create yours. The consistency of your world? Actually, this one deserves more attention. We'll come back to it. The philosophical problem here is profound. All of your evidence that you're real is inside your head. Your memories are neural patterns. Your perceptions are neural patterns. Your thoughts are neural patterns. And all of those patterns could, in principle, form spontaneously through random fluctuation. This connects to a deeper problem in philosophy called the problem of induction. How do you know the future will resemble the past? How do you know that the sun will rise tomorrow, that gravity will keep working, that the laws of physics won't suddenly change? The answer is you don't. Not with absolute certainty. You have evidence, based on past experience, that the universe is orderly and predictable. But that evidence comes from memories, and a Boltzmann brain would have the same memories. As you lie there tonight, breathing slowly in the dark, you have a powerful intuitive sense that you're real, that your past actually happened, that the world around you, though you can't see it right now, continues to exist. This intuitive sense feels absolutely trustworthy. But feelings of trustworthiness prove nothing. A Boltzmann brain would feel the same trust in its own reality. That's the whole problem. Some philosophers have argued that this makes the Boltzmann brain scenario self-undermining. If we can't know anything at all, if even our confidence in logic and evidence might be illusory, then we can't even have this conversation. The very act of reasoning about Boltzmann brains requires us to trust our reasoning, which we couldn't do if we really thought we might be momentary fluctuations. This is a form of pragmatic argument. We must act as if we're real, so we might as well believe it. But this doesn't solve the paradox. It just tells us how to cope with it psychologically. The mathematical problem remains. In an eternal universe, Boltzmann brains dominate. Most observers should be fluctuations. You should be a fluctuation, and yet you don't seem to be one. Something is wrong somewhere, either with the cosmology or the physics or apart all matter or some other cosmological catastrophe. Then Boltzmann brains might never have time to dominate. The problem is that our current best models suggest the universe will indeed last forever. Dark energy is accelerating the expansion, and nothing in known physics predicts it will stop. We'd have to discover something new, some mechanism that ends the universe on a finite timescale, to make this solution work. Solution 2. Maybe there's something special about now. Perhaps we live in an early, atypical era of cosmic history. The Boltzmann brains might come later, much later, in the far future when the stars have burned out and the cosmos has cooled. Right now, during this brief window when galaxies shine and planets host life, biological observers might still dominate. This is true as far as it goes. We do live in a special time, cosmically speaking. But it doesn't really solve the paradox, it just delays it. Over infinite time, the Boltzmann brains will still win eventually, and by such an overwhelming margin that our era becomes a negligible anomaly. Solution 3. Maybe consciousness requires more than a brain. This is a fascinating possibility with profound implications. What if a brain by itself isn't enough for genuine consciousness? What if awareness requires a brain that's actually connected to a body, to an environment, to a history? If consciousness requires integration with a real physical world, if a brain floating in a void simply wouldn't be conscious, no matter how perfectly arranged its neurons, then Boltzmann brains wouldn't be observers at all. They'd be complex arrangements of matter with no inner experience, and the paradox would dissolve. This solution depends on questions about the nature of consciousness that we can't currently answer. We don't know whether a perfectly structured brain would be conscious in isolation. Some theories of consciousness suggest it would be, others suggest it wouldn't. Until we understand consciousness better, this remains an open possibility. Solution 4. Maybe the quantum vacuum doesn't work the way we think. Our predictions about Boltzmann brains depend on assumptions about quantum fluctuations that might not be correct. The vacuum might be more stable than we think, or fluctuations might be suppressed by mechanisms we don't understand, or the whole framework of eternal inflation might be wrong. This is possible but feels like avoiding the problem rather than solving it. We'd need positive evidence that the vacuum doesn't allow Boltzmann brains, not just hope that it doesn't. Solution 5. Maybe we need to rethink how we count observers. This is where things get philosophically deep. The Boltzmann brain paradox assumes that we should expect to be a typical observer, that if most observers in the universe are Boltzmann brains, we should probably be Boltzmann brains. But what does typical mean? How do you count observers in an infinite universe? These questions turn out to be surprisingly tricky, and different ways of counting can give different answers. Some physicists have argued that the standard way of counting observers is wrong, and that a better approach would avoid the Boltzmann brain problem. Others argue that any way of counting observers will eventually run into similar paradoxes when you're dealing with infinity. This remains an active area of research, and there's no consensus on the right answer. There's one proposed solution to the Boltzmann Brain paradox that I find particularly compelling because it connects to some of the deepest questions about why our universe exists at all. Remember Boltzmann's original question: why is the universe in a state of low entropy? Why is there order instead of chaos, structure instead of uniform heat death? Boltzmann proposed that our ordered universe is just a random fluctuation in an eternal, high-entropy background. But this leads directly to the Boltzmann brain problem, because brains are smaller fluctuations than universes. What if Boltzmann was asking the wrong question? What if the low entropy of our universe isn't a fluctuation at all? What if it's a consequence of the way the universe began, of special initial conditions at the Big Bang? Think about what we observe when we look at the early universe. The cosmic microwave background radiation, the afterglow of the Big Bang, is remarkably uniform. It's smooth to about 1 part in 100,000. This tells us that the universe started in a very special, very low entropy state. If this low entropy beginning is simply a fundamental feature of our universe, if it's not a fluctuation but a starting condition, then the whole Boltzmann brain problem changes character. We don't need to explain our universe as one fluctuation among many. We don't need to compare the probability of our universe to the probability of isolated brains. Our universe is simply what exists with its particular initial conditions, evolving according to its particular laws. But this raises a new question. Why did the universe start with low entropy? This is sometimes called the past hypothesis, the assumption that the universe began in a highly ordered state. It's what gives time its direction, what makes the past different from the future, what allows entropy to increase and creates the arrow of time we all experience. Without the past hypothesis, there's no explanation for why we have memories of the past but not the future, why causes precede effects, why we grow older instead of younger. All of these asymmetries trace back to the low entropy of the early universe. But where did that low entropy come from? This is where cosmology starts to blend with philosophy. Some physicists argue that asking why the universe started with low entropy is like asking why anything exists at all. It's simply a brute fact about reality that doesn't have a deeper explanation. Others propose that the low entropy beginning was itself a fluctuation, but in a very different kind of space, a fluctuation in some higher dimensional reality that gave birth to our universe as a whole. Still others suggest that time itself might be emergent, arising from more fundamental timeless processes, and that the past hypothesis reflects something deep about how time relates to causation and consciousness. As you drift here in the quiet darkness, I want you to notice something. Your sense of time passing, your feeling that the present moment is slipping away into memory even as the future approaches. This ordinary, everyday experience might be a window into some of the deepest puzzles in all of physics. Why does time flow? Why is the past fixed while the future feels open? Why do you experience one moment after another instead of all moments at once? The Boltzmann brain paradox is intimately connected to these questions. And whatever the final answer turns out to be, it will probably transform our understanding of time, consciousness, and reality. The point is that the Boltzmann brain paradox might dissolve once we understand consciousness better. It might turn out that the kind of consciousness we have, the kind that remembers a past, perceives a present, and anticipates a future, can only exist in the context of a real history and a real world. If so, then Boltzmann brains wouldn't be competitors for the title of typical observer. They'd be empty systems, complex but without experience, like intricate machines that have no one inside. This is my favorite possibility, though I can't prove it's correct. It suggests that consciousness isn't just computation, isn't just information processing, but something that requires genuine embedding in reality. It suggests that you're real because only real minds can have the kind of consciousness you're experiencing right now. This feeling of lying in darkness, of thoughts arising and passing away, of presence and awareness. A Boltzmann brain might have neurons, but it wouldn't have this. Let's step back and consider what we've learned tonight from a different angle. Here's a strange fact. The universe produced beings who worry about whether they're real. Think about that. Matter organized itself into galaxies, stars, planets, organic molecules, cells, nervous systems, brains, and those brains became aware. Not just responsive to stimuli, not just processing information, but genuinely aware, having experiences, asking questions about the nature of existence. And among those questions is, are we just random fluctuations in an empty void? There's something almost paradoxical about this. The same physical processes that created stars and planets also created minds that question whether anything is real. The same universe that might produce Boltzmann brains also produced beings who can conceive of Boltzmann brains and worry about them. Some philosophers have suggested that this is a clue. The fact that the universe produces self-aware observers might not be an accident. It might be telling us something important about the nature of reality. The anthropic principle, in its various forms, points out that we can only observe a universe that allows observers. If the laws of physics or the initial conditions were slightly different, we wouldn't be here to notice. So it's not surprising that we find ourselves in a universe that permits our existence. But some thinkers go further. They suggest that consciousness might be woven into the fabric of reality at a fundamental level. That the universe isn't just matter in motion, but matter in motion that experiences itself. That awareness isn't an accident but an essential feature of existence. If this is true, then the Boltzmann brain scenario might be missing something crucial. It treats consciousness as a pattern that can be instantiated randomly, like a particular arrangement of puzzle pieces that can form either by careful assembly or by shaking the box long enough. But what if consciousness is more like a river than a puzzle? A river requires continuous flow, constant renewal, ongoing interaction with its banks and bed. You can't make a river by instantaneously arranging water molecules in a river-like pattern. You need the flow. You need the process. Similarly, consciousness might require the flow of time, the accumulation of experience, the ongoing interaction with a real environment. It might not be something that can simply pop into existence, fully formed from a random fluctuation. This doesn't solve the Boltzmann brain paradox definitively, but it suggests that the paradox might rest on assumptions about consciousness that aren't correct. And it points toward a different way of thinking about what you are. As you lie there in the darkness, perhaps close to sleep now, I want to offer you something that might seem strange. Comfort in not knowing. We don't know if you're a Boltzmann brain. We can't prove you're not. But we also don't know how consciousness works, don't know the ultimate fate of the universe, don't know whether the mathematical frameworks that predict Boltzmann brains are correct. And that uncertainty, I think, is appropriate. It's honest. It reflects where we actually are in our understanding. There's a temptation, when confronting a puzzle like this, to demand a definitive answer. Are Boltzmann brains possible or not? Am I real or not? Is consciousness computational or not? But some of the deepest questions don't have easy answers. And the discomfort of not knowing might be more truthful than false confidence in any direction. What we can say is this: the Boltzmann brain paradox has pushed physicists to think more carefully about cosmology, about the nature of time, about how to make predictions in an infinite universe. It has pushed philosophers to think more carefully about consciousness, about identity, about what it means to be an observer. These are good things. The paradox has been productive even though it's unresolved. It has shown us that our theories have implications we need to take seriously, and that some of those implications are very strange. And personally, I find a certain peace in the strangeness. The universe is not obligated to make sense to us. It's not obligated to be comfortable or intuitive. It is what it is, and we're part of it, and we're trying to understand it with brains that evolved for survival on an African savanna, not for grasping the nature of infinity. That we can even formulate the Boltzmann brain paradox is remarkable. That we can reason about it, argue about it, make progress on it, that's extraordinary. We are matter that has become conscious, is looking at itself, and is trying to understand what it sees. Whatever the final answer turns out to be, that's something worth appreciating. Let's confront this directly before we close. What if you are a Boltzmann brain? What if everything I've said about the paradox being unresolved is itself part of the illusion? What if you're a momentary fluctuation in an empty void, experiencing false memories of a life, a world, a universe, and in another instant you'll dissolve and be gone? Here's what I notice. If this were true, it wouldn't change anything about your experience right now. You would still feel the weight of your body. you would still hear these words. You would still have the thoughts and feelings you're having. The experience would be identical. And here's what else I notice. There would be nothing you could do about it. If you're a Boltzmann brain, you can't choose to be something else. You can't escape your situation. You can only experience what you're experiencing for as long as you experience it. So the question, am I a Boltzmann brain, might be less important than it seems. Not because the answer doesn't matter in some cosmic sense, but because it doesn't change anything about how you should live, or in this case, how you should fall asleep. What matters is this moment, this breath, this awareness. If you're a real person with a real history, then this moment is part of an ongoing story, a story that will continue when you wake up tomorrow. If you're a Boltzmann brain, then this moment is all there is, and it's still real as an experience. It's still consciousness being conscious. Either way, you're here now. Either way, you're aware. Either way, something rather than nothing is happening. And maybe that's enough. We've traveled a long way tonight, from 19th century Vienna to the quantum vacuum, from the mathematics of infinity to the mystery of consciousness. Let me bring us back to something simple. You exist. In this moment, something that calls itself you is having an experience. It feels the softness of the pillow, the quiet of the room, the gentle heaviness that comes when the body prepares for sleep. This experience is certain. Whatever else might be true or false, the experience is happening. Descartes knew this centuries ago. You might be deceived about almost everything, but you cannot be deceived about the fact that you're having experiences. The Boltzmann brain paradox questions the context of your experience, whether there's really a world around you, whether your memories are real, whether you have a past and a future. These are legitimate questions. They might not have comfortable answers, but the experience itself is beyond doubt. Consciousness is happening. Awareness is present, and there's something almost miraculous about that. Isn't there? That anything should be aware at all. That existence should include not just matter and energy, not just particles and forces, but experience. That there should be something it's like to be here. The universe could have been just objects moving according to laws. Could have been processes without perspectives, happenings without awareness. But it's not. It includes this, whatever this is, this sense of being present, of being here, of being aware. That seems worth appreciating regardless of what you are. The night is deep now, and perhaps your thoughts have begun to blur at the edges, the way they do when sleep approaches. Let me leave you with this. Tomorrow, if you wake, and I believe you will, you'll probably feel that tonight's paradox was interesting but abstract. You'll go about your day, interacting with a world that feels solid and real, remembering a past that feels definite, anticipating a future that feels possible. And that's fine. That's how it should be. We can't live in constant philosophical vertigo. We have to act as if the world is real because for all practical purposes it is. But maybe, sometimes, in a quiet moment, watching the stars or lying in bed on some future night, you'll remember this paradox. You'll remember that our best physics suggests the universe will last forever, and that in forever, strange things become inevitable. You'll remember that we don't fully understand consciousness, and that this ignorance is crucial to some of the deepest puzzles about existence. And maybe you'll feel something I feel when I think about this, a kind of awe that's mixed with humility, a sense that reality is stranger than we usually allow ourselves to notice, a reminder that we're small creatures on a small planet, trying to understand something vastly larger than ourselves. The Boltzmann brain paradox probably won't be solved by any individual insight. It will be solved if it's solved by slow progress in cosmology, in physics, in neuroscience, in philosophy. It will be solved by many minds working together over years and decades, building on each other's ideas, gradually assembling an understanding that none could reach alone. That's how human knowledge works. That's the project you're part of, just by being a conscious being in a universe that allows conscious beings to wonder. Whatever you are, evolved mind or random fluctuation, ordinary person or cosmic anomaly, you're part of existence becoming aware of itself. You're part of the universe looking inward and asking what it is. That's not nothing. That might be everything. There's a version of you that exists for only 1 second. But there's also, I hope, a version of you that exists for a lifetime. A version that will wake tomorrow with genuine memories of today, including perhaps a memory of this video. A version that will continue to experience, to learn, to wonder. I can't prove that this version is the real you. The paradox doesn't allow such proof. But I believe it. I believe that you're a real person with a real history, listening to this in a real room, about to drift into real sleep. I believe that the universe, strange as it is, produced you through billions of years of cosmic evolution, and that this makes you, in some sense, a child of the stars. The stars that burned to create the elements in your body. The galaxy that held those stars. The universe that held that galaxy. The laws of physics that allowed it all. You're made of all of that. You're the universe experiencing itself, wondering about itself, preparing to rest and dream and continue. So let yourself rest now. Let the questions settle, like sediment drifting to the bottom of a still pond. Let your breathing slow, your thoughts soften, your awareness diffuse into that gentle twilight between waking and sleep. The paradox will be here tomorrow if you want to think about it more. Tonight, you've done enough. You've followed the rabbit hole all the way down. Now it's time to let go. Sleep well. And maybe, when you dream, you'll dream of a universe that dreams of you, a cosmos that imagines minds, and minds that imagine the cosmos, all of it entangled in a strange loop of awareness that neither began nor will ever quite end. That's the beauty of it. That's the mystery. Good night.